Okay, so that recording should have started. Well, thanks so much for joining this morning, this introductory webinar about CCC ParaSolS. My name is Kevin Handley at the University of Edinburgh, and I'm the project lead for this project. So today, what we're going to go through is what is CCC ParaSolS and who is involved. I'm not going to give all of this presentation myself. I have some assistants today. So I'll then hand over to Catherine O'Sullivan from Imperial College London, who is the project co-lead. She will tell you how you can join and become a member of CCC ParaSolS, and also a little bit on the planned activities that we're going to be working on for the next year and a bit. She will pass on to my colleague at the University of Edinburgh, JP Morrissey, who's the researcher co-lead on the project. He will talk to you about the network events that we've planned in the next year and a bit. We also have participation in this project from CoSeC, who are the Computational Science Centre for Research Communities. They'll talk a bit about what they do and their role in CCC ParaSolS. Then at the end, we'll have some time for questions from the audience, and hopefully we'll be able to provide some answers to those questions. Right, so what is CCC ParaSolS? This is a 2-year project that started only in January, so it's still early days, funded by the Science and Technology Facilities Council. What we are doing is creating a collaborative computational community in particulate solids simulations. I'll start with the second half of that first. By particulate solid simulations, we're talking about materials like the ones that you can see in the picture. So this might be soil, so sand grains. It could be cement or aggregates used in construction. It might be pharmaceutical powders, or even in your kitchen, you have particulate solids. You have probably flour, salt, sugar, dried beans. All of these are examples of particulate solids of interest in this project. We're not focused in this project on particles at an atomic or molecular scale. Roughly speaking, we're interested in particles that you can see with the naked eye. These particles are, of course, ubiquitous. They're everywhere in nature. They appear all over the place in industrial manufacturing. And of course, they arise in your everyday lives. What is a collaborative computational community? I'm going to amalgamate the idea of a collaborative computational community and a collaborative computational project because they're very similar concepts. It's a network of researchers in the UK joined together through the research software or associated data being used. A collaborative computational community is a precursor to a collaborative computational project. That is the idea. Now, later, we're going to have a bit of a presentation from CoSeC themselves, so they will give more information about the CCC model at that point. So I will be quite brief here in this introduction. This is a long-standing model. These collaborative computational projects have been around for decades. And the idea is to put research software on an infrastructural standing which is commensurate with the way we treat physical infrastructure. Research software is absolutely essential to producing some research outputs, and it should be treated as such. So what CoSeC do is they have projects to ensure that software development is compatible with the trends in digital research infrastructure. So, for example, that the software being developed can make good use of our high-performance computers that we have in the UK. They also have an interest in ensuring that software is properly maintained and distributed to people who would like to make use of it. More on this later. Why do we need a collaborative computational community in this area of particulate solid simulations? As many of you will be aware, these simulation methods, such as DEM, are becoming ever more popular. That is partly because we have access to more and more computational power, so it's becoming ever more feasible to run these simulations. But also, these simulations have lots of nice advantages. They're able to give you scientific insights into particulate behavior that is difficult, sometimes impossible, to obtain experimentally. DEM, as an example of one such method, can give you the position, velocity, and the forces acting on every particle in a system at every instant of time. So it's a tremendous amount of detail and insight can be obtained from these simulations. In addition, compared to other simulation approaches, these discrete particle-based simulation methods can be used to predictively model phenomena that you cannot capture with continuum approaches. They have lots of other benefits as well, such as excellent repeatability compared to physical experiments. When setting up a numerical particle-based simulation, you can place the particles exactly where you want them for many, many simulations. So you can start these simulations off from exactly the same point, which is useful, for example, for parametric studies. The etc. bullet point at the bottom of this slide probably encompasses at least 10 more advantages of these methods that you can think of, but we don't have time to go into here. So these methods are very powerful and are becoming more popular. The issue and the reason why we need a collaborative computational community is that developments of these methods are happening in disciplinary silos. By that, what we mean is that there are developments happening among the geotechnical engineering community and among the chemical engineering community, among physics researchers who use these methods, even among computational scientists who are developing algorithms so that these kinds of methods can run more efficiently. These communities tend not to communicate particularly well with each other. And that is a problem because it means that advances in one of these disciplines don't percolate to other disciplines who may be interested and who may benefit from their advances in a timely manner. The way to overcome this disciplinary way of thinking is by having an overarching community for the UK. So by having something like CCC ParaSolS. As is said on the slide, this CCC ParaSolS project embeds diversity and inclusiveness in all activities. When we say diversity here, we mean diversity in every respect. It's diversity of discipline. The community is open to people from all disciplines who simulate particle systems. But it's also diverse in terms of career stage. We want people at every career stage, from early career researchers right through to extremely experienced academics and industry participants. We do want people from industry and from academia. We, of course, want gender diversity in this as well, and so on. So a highly diverse community. Right, so who's involved? Your presenters today are the current management committee. Once I've finished my bit of the presentation, I'll be passing on to Catherine O'Sullivan, who in turn will pass on to JP Morrissey, who in turn will pass on to her colleagues from CoSeC. This current management committee on the slide will be expanded. We are going to appoint 6 members from the community with some constraints to ensure that we have diversity in terms of who we appoint. So we'll be appointing members to ensure we have at least one early career representative, an industry representative, at least one person representing research in the natural environment area, and at least 2 of those 6 appointees will be women to ensure a reasonable gender balance. This will be announced next week. If you are a member of our community, in other words, if you have signed up and completed the registration questionnaire, and if you would like to be part of the management committee, we would welcome your application. We'll be announcing this call for self-nominations next week. In addition to having a management committee, we have an advisory committee made up of these 6 people, some of whom will be familiar to some of the people on the call. The advisory committee has representation from academia and from industry. One thing that I would particularly like to highlight is that we have selected 3 open source DEM codes as the ones that are prioritized for consideration in CCC ParaSolS. We have representation from the developers of those 3 codes on the advisory committee. And most importantly, in terms of who is involved, people have been joining. Some of you on the call will already have signed up to the community, which is absolutely fantastic. We hope that everyone on the call will sign up quite soon. So currently the community has 40-something members. We had a little flurry of people joining up yesterday, so we've added a few since these numbers were updated. Currently, we have approximately an 80-20 split between academia and industry. We have probably a better balance between career stage. That's the middle pie chart, where we have quite a good mix of early career researchers and very experienced researchers. And on the right-hand side, we have some indications of discipline. Currently, we have a lot of members who are from civil or geotechnical engineering, less so from other areas. So something that we would like to do is attract more people from other disciplines to have a more diverse community. Now I'll hand over to Catherine O'Sullivan from Imperial College London, the project co-lead, who will take you through the next few slides.
Thanks, Kevin. Well, first of all, just to say I'm really excited about this because I think that is really going to be a game changer in the capacity of doing DEM simulations in the UK. And please do encourage other people to join because we need a bit of momentum to keep this going in the long term, and it's very important. This is a grant where we want as many people to join as possible. So JP designed this amazing QR code. I really like it, and you can click on that. You can share it on your social media, follow us on LinkedIn, and help to publicize this, especially because strategically in the long term, to maintain this momentum, we need to get some people outside of civil engineering. So I recognize the names. A lot of you are civil engineers. Do tell your friends, if you're a researcher, tell the other people in your group. But also if you know people in other departments, nudge them as well, because we want to get a body of momentum behind this so we can change what we can do with DEM. I think this is going to be really, really exciting. So you go to the website, you can join. Once you go to the website and join, I don't know if you want to move to the next slide, Kevin. There's a registration questionnaire, and that it's a bit annoying, to be frank, but we have to collate this information to satisfy the requirements of our funders, which is STFC under UKRI. And these data are really important so we can report to them on certain issues. So I hope you will be patient with us, fill this in. As well as these data that UKRI need, completing this questionnaire will allow us to better design the activities that we're going to run over the next, to the end of 2026. So I don't know, Kevin, if you want to move to the next slide. So there's some initial feedback about people's experiences in using DEM, what they want this CCC to deliver, and why they're joining CCC ParaSolS. And we can look at this and bear that in mind when we're planning our activities, which JP is going to talk about shortly. So what we're going to do is deliver training on using open source DEM codes and using high performance computing. And one thing I want to say is, through this system, we will be able to give you access to some high performance computing resources. And hopefully that's something we're going to be able to sustain in the long run through the CCP. And CoSeC will talk more about that, I think, later this morning. But that's something that we're hoping that we will be able to enable. But at the same time, we want our software to be doing things accurately, delivering high quality, robust science, either in research or in applications in industry. So we want to develop benchmarking cases and look at how you use these pieces of software properly. And then we're going to be promoting open source software. And I think that's crucial, because we can't all get the funding needed to buy commercial software. One of the really nice things about this area of research is you can do fundamental science that's not incredibly expensive if you know how to use these open source codes properly. And I think that's really democratizes fundamental research, and I'm very, very excited about that. But we want to support that in this validation and benchmarking so that the science that's delivered, as I already said, is robust. So how are we going to do that? We're going to have networking events, in-person events, and JP is going to talk in details about the schedule for the next one. We're going to look at what people need. Where are the gaps in our capabilities? What do we need to do with these codes that would then enable us to do science that's relevant in the UK? And knowing these gaps, we're going to be able to take on some code development projects so that we enable this software to tackle problems that are relevant in the UK. And then we're going to be thinking forward for what's going to happen in the 5 years after 2026. Kevin, have I said anything incorrectly there? So there's going to be 3 events over these 2 years, workshops, networking events, research dissemination, and training. And I think at this point, I pass over to JP, who's going to talk about the next event. Is that right? Or do I need to do, is there a couple of more slides? A couple of more slides, okay. There's also going to be some virtual events, such as today's introductory webinar. And all of these are going to be expanding our community, but also supporting new users, people who haven't used HPC before, people who haven't used GPUs before. Let's enable these to start using this technology and make it accessible, again, with this idea that we want as many people as possible to be able to do good, high quality, fundamental and applied research in the UK. Maybe the next slide is the last one for me, isn't it, Kevin? So the codes we're going to look at are LAMMPS, Mercury DPM, and YADE. We're going to be looking at high performance computing by running simulations on Archer 2. And then we're going to be looking at post-processing of data. DEM simulations generate a lot of data. And also what's very important, and I say this from, some of you know I'm the editor of a journal, and one of the things that's happening in scientific publication now is to make sure that the data underlying our papers is accessible. And participating in this CCC will give you the tools in order to be able to maintain data in such a way that you have this openly accessible data sets that would underpin the highest quality papers and increase your scientific impact. So I think that's another reason why this is going to really help to advance science in the UK. So we're going to look at best practice guidelines on reproducible research, how we're going to use the codes effectively, how we set up our simulations, and really starting from assuming, that some of our community have never done this before, and then upskilling those who have some experience. And we've got time from developers to look at how we modify the codes, as I've already said, to match your requirements for your basic and applied research needs, be it in academia or in industry. Now it's JP. You're on mute.
Yep, I'm on mute. Thank you, everyone. Thanks, Catherine. Thanks, Kevin. So I get to talk about, well, what the first event, which is welcoming you all to Edinburgh. So we're going to host our first event, 14th to 16th of May. And we're going to be inviting all CCC ParaSolS members to register interest in attending the event. So if you go to the ParaSolS website, and more specifically the page for event 1, there should now be a sign-up form to register interest and click through and fill out the details saying that you'd like to attend the event. What you can see is Edinburgh is quite a beautiful place. We can't guarantee the sunshine, so that's a good enough excuse to come anyway. But you have until about the 22nd of April to decide on whether you would like to apply for or not. And we'll be passing out our responses by the 25th of April, and allowing people reimbursement if they request to do so. So like I said, you can follow the link to the website and read a bit more about what we have planned. But I'll just go through what we're going to be doing in the event one now quite briefly. So the first day starts on a Wednesday, and we're maybe doing something a little unusual for some people, which is starting around lunchtime. But for other community members, such as our GM3 members, this is quite normal for a late arrival to allow people from around the UK to travel. So we will have an arrival and lunch, and then we kick off at around 1 o'clock that day, where we'll be doing in-person introductions, and we will have an introduction to basically the history of DEM and simulation of particles to get us started and to refresh our memories on some of those interesting early ideas. But we'll also have a nice showcase of experience, because this is a community event. We're going to have people from across the community and career stages and various roles, academia and industry, to basically tell us about what they like, dislike, how they found using DEM, problems they've had, and so on, to get people started understanding what is going on. After lunch, what we will have is a facilitated workshop, basically to introduce the DEM codes, the use of HPC and GPUs. So this will be to talk about problems and how we can help, and what we can do to improve things. And then obviously we'll have one of our event dinners. This is a 3-day event, so you actually get 2 free dinners, which is probably a good enough reason to sign up as well. But on the second day of the event, that's where we, I guess, start the real hard work, or maybe the real interesting work, depending on which way you look at it. But we will jump into learning about the various DEM codes. And as already mentioned, we're going to be focusing on 3. So on the Thursday morning, we will look at introductory session to using Mercury DPM. After lunch, and then we will be doing training on lamps, and again, these are relatively long sessions, so that you have time to work through the tutorials, ask questions if you get stuck, and so on. Obviously, we will have tea and coffee breaks in there, and we're not going to be forcing you to work for 3.5 hours. On the third day, on Friday morning, we continue with our third code, which is going to be YAID, and again, we will have our training up until lunchtime. And then in the afternoon, after lunch, we will have an Ask the Experts panel session to open discussion on code capabilities, how to deal with specific problems, and so on. And before having a short closing remarks ceremony. And as Kevin already mentioned, one of the things we obviously wanted to do is promote diversity and inclusivity across the community. So one of the first ones we're trying to do is in this workshop, we're going to be promoting career development, and we have a workshop for women, which will be hosted on the Friday afternoon then as well. And then everybody is free to go explore Edinburgh or head back home and enjoy their weekend, and hopefully have enjoyed a 3-day event. As already mentioned, we're going to have a couple of other events. So event 2 currently is going to be somewhere in England and probably around mid-October. And in this event, we'll be talking about using lamps and specifically HPC and our Archer 2 national computer. So running some large-scale DEM examples on Archer and learning about it. Our third event tentatively is going to be hosted in Northern Ireland, probably in March 2026. And hopefully this will be a joint event with ONDEM. If you're a DEM user and you're not quite sure what ONDEM is, you can follow through to the ONDEM website from the link on our own website and read about what the ONDEM community is doing. So those are our 2 physical events that we will be running. For all of these events, we are able to reimburse for travel and accommodation. For some attendees, obviously, we have a limited budget and we can't accommodate everyone in that sense, but we will try and spread as much as we can around. And these events should be available online for everybody should they wish to attend, but be unable to travel on the particular dates that are chosen. So this is where I introduce CoSeC, and Stefano is going to take over now and tell us a bit about what CoSeC is and what CoSeC does, and maybe what its role within CCC ParaSolS will be. So over to you, Stefano.
Thank you. Just give me 1 second that I'm sharing my screen. Okay, can you see my screen?
Yes.
Perfect. Okay, CoSeC was mentioned several times. I will try to give you an idea about what is CoSeC, where it is coming from. Here is a set of slides that was delivered by the CoSeC director, Stephen Longshaw, also at other events. I will also introduce not just only CoSeC, but a little bit the landscape around where CoSeC sits within our organization and within UKRI. First of all, what it is CoSeC? As you can see, CoSeC is a UKRI funded center to deliver and enable collaborative computational research. Our computational research is really focusing, as Kevin already mentioned in his presentation, on software development and developing software as an infrastructure, as an asset that after can be used throughout the community to deliver research and potentially also a little bit more. We are funded from UKRI, but we are part of STFC, the Science and Technologies Facilities Council. I will just only take a minute to tell you what it is STFC, because it's generally a bit a weird creature within the UKRI landscape. The mission of STFC is to deliver world-leading national and international research, and also support innovation. We do this through 4 main sort of path. The first one is funding for frontier science, and as you can see over here, generally what STFC funds is research in particle physics, nuclear physics, and astronomy. This is not very different from your potential usual research council, being EPSRC, NERC, MRC. However, already over here, there is a little bit of difference, because while the other research council tends to fund UK institution, for example, STFC is also paying the UK contribution to NERC. Therefore, as you can see, STFC already also from the funding point of view, a sort of international outlook. The other, and potentially the largest, particularly in terms of people, activity that we do is world-class facility. By facility, we mean particle accelerator, laser, light sources, and so on and so forth. This very big experimental facility that underpin a lot of research, for example, in material science. And for this reason, we have got, while most of the other research council are based around Swindon in Polaris House, STFC has got also a lot of laboratories dotted around the country. For example, the biggest one is Rutherford Appleton Laboratory, nearby Oxford, but we've got also other locations. For example, the one where myself, Christo Volantis and Dave are located is here in Dasbury in the northwest of England. We've got also a presence in Edinburgh at the UK Astronomy Technology Centre, and so on and so forth. While we support science, all our laboratories are sat around Innovation Campus. Where we are located, we are not really doing research in a silo, but we are part of a campus where there are a lot of companies. For example, here in Dasbury, we have got IBM R&D research that we work with. We have got PsiQuantum, that is one of the new startups that is trying to delivery on quantum computing, and so on and so forth. As you can see, that we try to foster a collaboration between upstream research and create impact, moving this research into UK industry. And also, we create a lot of focus cluster. For example, around Rutherford Laboratory, there is a large cluster that means university and company around the thematics of aerospace. For example, in Rutherford, there is also an ESA present, an Airbus present, and so on and so forth. Within STFC, CoSeC sits in scientific computing. It is one of the department which is part of the STFC national laboratories. As the name says, we provide support for computational science and computational infrastructure. And we also deliver some science in the fields of, for example, material science, engineering, and so on. We are about more than 300 RTP, research technical professional. And for people that are not really familiar with this term, it means the classical RSC, but also computational scientist is a more general term to really encompass all the people that are working on the landscape of research infrastructure. Our department is one of the few that is located at our both major laboratory. We've got a presence here in Dasbury, where myself, Dave, and Volantis are located, but also a large part of the department is located in Rutherford Laboratory nearby Oxford. What it is CoSeC and computational research? Computing in general, and this was already mentioned by Kevin, is really a powerful tool that underpin and supports research, both as an indirect mechanism. For example, a lot of our facilities that are experimental, they've got a large need of computational tools. For example, a particle accelerator produce a large amount of data, and you need to do a lot of data curation on this data immediately when they are produced. You need to do already some compute in order to properly store them, make them analyzable, and so on. Therefore, even for large experiment, you've got a large requirement for computing. And indeed, as was mentioned before, computing can be also a primary mechanism to do direct research. What CoSeC gives is basically access to a pool of RTP with different experience. For example, we've got expertise in data science. We've got domain specialist expertise. For example, we've got Volantis that got already quite a lot of experience in DEM research and more in general on particle related research. We've got expertise in GPU porting, and we are also starting to do to provide support on AI, quantum computing, and sustainable green computing. What it is the CCP model? This is a model that, as Kevin said, started back in the 70s. The first CCP, I think, was created in 1972, and it was about crystallography, basically all material science. From there, more and more community have been created, but they all have some common feature, and particularly at the center of every CCP, there is the development of algorithm, the development of theory that support the algorithm, and the creation of computer codes in order to enable the community to proper do the research and to have tools that they got a long-term support. One of the big issue with grants is that you might get a bit of a grant to support some research, but basically this activity needs to stop at the end of the grant. With this model, we will try to create a sustainable path for this software development. We've got community that span several research council. As you will see in a moment, we've got CCP that are operating in the EPSRC, in the MRC, in the BBSRC, and in the STFC space. This was also mentioned before. We've got two flavors of the support that we give. CCP, the collaborative computational project, that are really more focused on software, algorithm development, and the HEC, the high-end computing consortia. These instead, they still have got a little bit of element of software development. However, they've got really at the core of this, there is the distribution throughout the community of compute time on UK national facility. What we will cover over here is mainly around the CCP. Generally, at the moment, the last call for HEC was run, if I remember correctly, a couple of years ago, and will continue until the end of 2026. Here is to give you an idea about what it is the current landscape. As you can see, we have got 4 major areas where the CCP and the HEC are operating. We've got materials, we've got computational biology, we have got imaging that is extremely important, particularly connected with experiments like laser, particle accelerator, and so on. Engineering, and we've got that is where myself, Dave, and Volantis sit on. We've got a project on turbulent flow in general, more specifically on nuclear thermal hydraulics, on wave structure interaction. And as you can see, in this case, we've got both sister project, like for example, CCP Turbulence is looking after the development of some community library and solver for the UK turbulence community, and UKTC is the vehicle that we provide some compute time through the to the community. As was mentioned, around the end of 2024, there was a call that enabled the establishment of CCP ParaSolS to create new communities, and this is the last pillar that is here at the end. And you can, as you can see, beside this one, new community have been created. For example, there is one that support the AHRC, the Arts and Humanity Council. There is a new community on computational mechanics. There is one, for example, on numerical relativity, and there is another one again related to STFC on basically theoretical and experimental particle physics. We have got also some activity that span out throughout all the pillars, and they've got some impacts on all the community, which is, for example, the CCP quantum computing that is trying to enable quantum computing and try to look what are the needs for quantum algorithm in all the different communities. We've got also some other activity related to data science, and particularly on fair data, that potentially are more across the whole family, the whole pillars of the communities that we support. That's it from me. If I will stop sharing and I will give you back the screen. Oh.
Perfect. Thank you very much, Stefano. So I'll share my screen again just for the last couple of slides, and then we'll take questions after that. So in summary, what we're doing in CCC ParaSolS is initially developing this cross-disciplinary community. This is something that's ongoing and is not going to stop at any particular point. People will be welcome to join the community essentially at any point. But obviously it would be most beneficial to be within this community from the start, because you can then participate in the training and help to shape the community and its activities. As JP and Catherine mentioned earlier, we'll be delivering some training, in fact, quite a lot of training within the network events. Towards the end of the project, we will produce a 5-year vision for our community and particulate solid simulations. And once we have that 5-year vision for the community and a cross-disciplinary community, putting those things together mean we'll be in a good position to create a viable plan for a collaborative computational project, which is the follow-on from the collaborative computational community. This is the mechanism by which, hopefully, this 2-year project will persist into the long term. So that's it. Thank you very much for your attention. We have time for questions now. If you do have any questions after this webinar, then by all means, email parasols@ed.ac.uk and we'll get back to you. Also worth mentioning that thanks to JP's efforts, we have a LinkedIn profile. So feel free to follow us on LinkedIn. And if you haven't already signed up to the community and completed the questionnaire, then the best time to have done that is at the start of the project, but now is the second best time before the first event in May. So thank you very much for your attention. If there are questions, feel free to, yes, raise your hand, or you could type them into the chat as well. So Donna, you have a question.
Hi.
It's actually me. It's Anthony who has the question, not Donna.
Oh, sorry.
Just a quick, very stupid question. Should I'm moving back to the UK. Should I sign up or not? Given I'm already on the other committee, I should have asked this privately. Should I sign up?
Sign up, Anthony.
Sign up. Thank you. Will do. All right.
Thanks.
Any other questions? Again, feel free to type questions into the chat as well.
I guess Donna got her hand raised.
Yes, I think that was Anthony's question.
Yeah.
Okay. Then was okay. Was still raised for this reason I ask.
An old hand. Catherine, yes.
This is a question for Stefanos. Just wondering, do you encourage us to have links with the other CCCs, or do you see them as being separate entities?
No, we encourage to have a cross-community exchange because the effort that has been given to us is not really massive in the grand scheme. Therefore, we really need to create overlap and try to see when there are similar needs in order to join the effort and make a little bit more a better use of the resources that we have got available. I think Kevin has already been invited to general meetings, CoSeC meetings, and we will try throughout the years. There will be general CoSeC meeting. We will pass all the invitation and we will distribute these throughout all the community. It's quite important that you try to establish link with other communities that potentially might do something that is very, very similar to what you have got in mind. I've got an example. For example, one of the new established community, the one on numerical relativity, despite looking extremely different, has got a lot in common with one of the long established community on turbulent flow, because at the end they all try to solve PDE, slightly different, but they are not millions mile away. And a lot of the technology that they are developing, for example, automatic mesh refinement on structural grid and so on, they are the same between what you will use on a DNS code and what you will use on a code for numerical relativity.
Okay, excellent. Liang, I think you were first.
Can you hear me?
Yes.
Yeah, okay. I got a question regarding the first workshop. So what's the a form of the workshop? Is that just kind of like presentation like one, or we also need to download the software onto our PCs and just also exercise these during the workshop period? So what I'm asking is, because it looks like we're only joining online. I don't know if I need to get some facility ready to join the workshop.
It's a very good question, actually, and something we should have addressed. So I'll skip back for a moment. Well, on the first day, you don't have to do any preparatory work for the first day. I guess you're talking about the training that will be delivered on these 3 codes.
Yeah.
We're currently exploring with Stefano and his colleagues at CoSeC about how to make things as easy as possible for the attendees. There's basically 2 options we're exploring. The first is a cloud platform, so that attendees, whether online or joining in person, would be able to access this cloud platform through a laptop, just through a browser, so you won't have to install anything in advance. And through that platform, you would then have access to the 3 codes we'll be using that will be ready for you to use. So that should make things nice and easy.
Yeah, that's much easier.
Yeah, if it works. So we're still exploring that possibility.
Yeah. Just to interject over here, we have done this for several other community before. STFC got this cloud platform. Basically, we can create 20, 30 virtual machine for every single user, where the environment will be a Unix-based system. Therefore, people might need to be a bit familiar with using a Unix system. But basically, you will access a desktop via web browser, and I tested with almost all web browser. All generally works. Therefore, from the user point of view, if everything is okay, you will get a login, you will enter over there, create your virtual machine, and you will be able to go. It should take about 5 minutes.
Yes, that's the preferred option, I think. That sounds neat. The other option is we have Linux computing labs, Unix computing labs here. and we'll work it out with our IT people, so that people attending physically will just sit in the computing lab. And again, we will have pre-installed all the software that'll be needed. We would have to work something out for people joining online. So hopefully the cloud thing will work out with Stephanie. Donna, you had a question. Or Anthony.
Actually, sorry, Kevin, it's me again. It was a question for Stephanos. Sorry, it's just so a lot of things you presented, like the GPU stuff, the quantum computing, I know very little about as a developer of the code, So I was hoping, it's just a general question. I hope from this project I can get some more skills from you guys. You have a lot of skills clearly presented. I would like to know myself, even as a code developer. And I'm hoping what this project is an opportunity to even the developers of code, well, just the users learn more stuff. Is that true? I hope that happens. Anyway, maybe it's a comment rather than a question. But you see my point. Yeah. Sorry.
Yeah, it's more a question for you, Stefano, about that.
Yeah, you can interact with all the people in CoSeC and so on. We have got, for example, our department is running a yearly event called CI UK that generally every year is in Manchester, and as part of this event there is a dedicated session, a dedicated day on CoSeC, on all the community, on all what we do, and people are more than welcome. Generally is for free. People are welcome to come, and over there you can have you can start to interact not just only with the direct CoSeC people, the one that sit inside STFC, but also the wider community with other people that are dotted around the university. Because in all CoSeC community there are these two components. There is the STFC part, but there is also the university part, and in some cases the university partners are many.
Excellent. Any other questions from anyone? John.
Hello, nice to meet you. My name is
Hello.
Juan, and I have one like little bit high level question. So, are you more just interested about doing like research using DEM? What I'm asking is because I time to time using DEM to teach a student or like open day I utilize it, and because it's fascinating without explaining all the complex boundary value problems, or without still I can deliver all the fundamentals to the general audience. But I'm not sure like is this community also or like at this moment is is it our interest basically, then can it like interest to like develop some more like low level interactive DM like API like applications, and is this like a kind of like a topic we can discuss in this context, or is it more really research oriented one? So I just wondering.
Well, it is general, so I'll again skip back if I can find the right slide. It's probably not the right one. So essentially, it's people in the UK, which here we've identified as researchers, but it includes people from industry, from academia, from anywhere, who are joined together by a shared interest in particulate solid simulations. So no matter what you are doing with simulations, whether you're a developer or a user, if you've never used a particle simulation before, you're more than welcome if you just have an interest in it. We want this community to be maximally diverse. So based on what you've been describing there, yes, I think you'd be perfectly fitted to join this community.
Thank you very much for the answer.
I think, Kevin, that Wanchun's asking a slightly different question. He's asking, would we look at developing tools for teaching people about granular materials? I'm not sure that's something we discussed before, but we can think about it, can't we?
We can indeed, yes. Hayden.
Hello. So for the training for the 3 different softwares, are you imagining setting up the same simulation on the 3 different softwares, so the same system, or will you choose different systems to showcase the strengths of each of the softwares?
It's a good question. We haven't discussed it yet. Open to suggestions on that. So we'll definitely be talking to the developers and the people who will be delivering the training, but it's not something that we have discussed yet.
Thank you.
Anthony or Donna?
So it's just a follow-up question. Which would you prefer is my question. Would you be better to see the same system in every software, or would you like to see the strengths? Which one would you prefer? Just out of curiosity.
That's not for me, really. I think it's for multiples. Catherine, JP.
Yeah, it was aimed back at the previous.
Yeah.
I think there's advantages to doing it both ways, but if we are able to show a wide range of different problems being solved, then that might be more interesting than just showing 3 ways to solve the same problem. But as Kevin and has already said, we haven't really discussed this in any amount of detail yet. But it's something for us to consider, and again, we're open to feedback from the community as to what would suit people best.
We are a bit constrained by what the developers themselves can do, because if they're doing the training, you know, they may be delivering something they previously prepared. So I think, from my end, I think we're slightly constrained in that some of this is being done on, we're not paying them. So we will be constrained a bit by that. But it's really, that's a good thing for us to discuss, isn't it?
Yes. So
we can have a chat with that with our advisory committee and try and come up with something, a plan.
Yeah, absolutely. That's a very good point to raise, Hayden. Any other questions from anyone? Fantastic. Well, if anything does occur to you after this webinar, then if you click on that email address, then drop us an email and we'll do our best to get back to you swiftly. The recording of this and the slides will be made available online. So if there is someone who could not make it today because of a clash with something else, you could direct them towards that if they're interested. And otherwise, thank you very much for your attention and for joining today. We hope you'll be able to join us in Edinburgh, be it online or in person, in May. See you.
Thanks for leading this, Kevin. Thank you. Bye-bye.
Bye-bye.
You all. Bye.
Kevin, I'm just going to